Tornadoes are one of nature's most awe-inspiring and terrifying displays of power. These violently rotating columns of air, often visible as a funnel-shaped cloud extending from a thunderstorm to the ground, can pack winds exceeding 300 miles per hour. The sheer force of a tornado can rip buildings apart, hurl debris for miles, and devastate entire communities in an instant. Tornadoes are a fascinating meteorological phenomenon. They form under specific atmospheric conditions, typically involving warm, moist air colliding with cold, dry air. This clash creates instability, and when coupled with wind shear, a change in wind speed and direction with height, it can cause a rotating updraft within a thunderstorm. As this rotating updraft intensifies, it can stretch downward, forming a funnel cloud. When this funnel cloud touches the ground, it becomes a tornado. The unpredictable nature of tornadoes lies in their formation. They can develop rapidly, sometimes within minutes, and their path of destruction can be erratic and difficult to anticipate. Tornadoes are most common in the spring and early summer, when warm, humid air from the Gulf of Mexico collides with cooler, drier air from the north. However, as we've seen in recent years, tornadoes can occur at any time of year, and in places not traditionally associated with these storms. Stay informed and prepared. Subscribe to our channel for more survival tips and weather updates. Understanding the power and potential for destruction of a tornado is crucial for effective preparedness and response. To gauge the intensity of these storms, meteorologists use the Enhanced Fujita Scale, or EF scale. This scale, implemented in 2007, replaced the original Fujita scale developed in 1971. The EF scale classifies tornadoes into 6 categories, ranging from EF0 to EF5, based on estimated wind speeds and the degree of damage they cause. EF0 tornadoes, the weakest on the scale, have wind speeds of 65 to 85 miles per hour, and can damage trees and cause minor structural damage. As we move up the scale, the intensity and potential for destruction increase dramatically. EF1 and EF2 tornadoes, with wind speeds of 86 to 135 miles per hour, can tear off roofs, overturn mobile homes, and snap or uproot trees. EF3 tornadoes, packing winds of 136 to 165 miles per hour, are considered strong tornadoes. They can cause significant damage to well-constructed homes, flip over trains, and uproot large trees. EF4 tornadoes with wind speeds of 166 to 200 miles per hour are classified as violent tornadoes. These storms can level well-built homes, toss vehicles, and hurl heavy debris at incredible speeds. The most intense and devastating tornadoes are categorized as EF5, with wind speeds exceeding 200 miles per hour. Predicting tornadoes is a complex and evolving science. Meteorologists use a variety of tools and technologies to monitor atmospheric conditions and issue timely warnings, giving people precious minutes to take cover. One of the most essential tools is Doppler radar, which uses the Doppler effect to detect precipitation and measure its motion. Doppler radar can identify rotation within thunderstorms, a key indicator of potential tornado development. By analyzing the movement of raindrops or hail, meteorologists can detect the telltale signs of a rotating updraft, known as a mesocyclone. While Doppler radar has significantly improved our ability to detect tornadoes, it's not a foolproof system. Tornadoes can form and dissipate rapidly, sometimes faster than radar can update. Furthermore, radar beams can be blocked by terrain or heavy precipitation, limiting their effectiveness. In addition to radar, meteorologists rely on sophisticated computer models that simulate atmospheric conditions. These models ingest vast amounts of data, including temperature, humidity, wind speed and direction, and precipitation, to predict the likelihood of severe weather, including tornadoes. While these models have become increasingly sophisticated, accurately predicting the exact location, timing, and intensity of tornadoes remains a challenge. Tornado Alley, a term coined in 1952, refers to a region in the central United States where tornadoes are most frequent. This area, traditionally encompassing parts of Texas, Oklahoma, Kansas, Nebraska, South Dakota, and Colorado, has long been synonymous with the threat of these devastating storms. The unique geography and climate of Tornado Alley contribute to its tornado-prone environment. The flat, open terrain of the Great Plains allows for the unobstructed collision of warm, moist air from the Gulf of Mexico and cold, dry air from the Rocky Mountains. This clash of air masses creates instability, while the presence of the jet stream, a fast-flowing air current in the upper atmosphere, can enhance wind shear, further fueling tornado development. However, in recent years there has been a noticeable shift in tornado activity, with a trend toward more tornadoes occurring outside the traditional boundaries of Tornado Alley. This eastward shift in tornado risk has led to the emergence of a new area of concern, Dixie Alley. Section 5. The Rise of Dixie Alley, a new frontier for tornado threats. Dixie Alley, a region encompassing parts of the southeastern United States including Mississippi, Alabama, Louisiana, Tennessee, and parts of the Ohio Valley, is experiencing a surge in tornado activity. This shift in tornado risk is attributed to a combination of factors, including climate change and natural climate variability. As global temperatures rise, the Gulf of Mexico is warming, leading to increased evaporation and moisture in the atmosphere. This warm, moist air can fuel thunderstorms and contribute to conditions favorable for tornado development. Additionally, changes in atmospheric circulation patterns, potentially influenced by climate change, are altering the paths of storms, steering them toward Dixie Alley. The rise of Dixie Alley as a tornado hotspot is concerning because this region is densely populated, and many communities lack the infrastructure and preparedness measures that have been established in Tornado Alley over decades. The combination of increased tornado risk and lower levels of preparedness poses a significant threat to life and property in Dixie Alley. Section 6, 2024, a year of record-breaking twisters. The year 2024 witnessed a hyperactive tornado season, with a record-breaking number of tornadoes reported across the United States. By May, over 1,100 tornadoes had touched down, nearly double the 30-year average and second only to the unprecedented tornado outbreak of 2011. Tornadoes occurred almost daily in May, impacting areas from Texas to Minnesota and east to West Virginia and Georgia. This surge in tornado activity was attributed to a combination of factors, including a persistent La Niña pattern in the Pacific Ocean, record heat in Mexico and Texas, and cooler-than-normal conditions in the Rockies and northern United States. These conditions created a volatile atmospheric setup with frequent clashes of warm, moist air and cold, dry air, fueling intense thunderstorms and tornadoes. The 2024 tornado season underscored the increasing frequency and intensity of these storms, as well as their expanding geographic reach. The traditional boundaries of Tornado Alley are becoming less defined, with tornadoes occurring in areas not historically accustomed to such threats. Section 7, Living with the Whirlwind, Life on the Edge of Tornado Alley. For residents of Tornado Alley and other tornado-prone regions, the threat of these storms is a constant reality. They live with the knowledge that their homes, businesses, and lives could be upended in an instant by the unpredictable fury of nature. However, rather than living in fear, they have adapted to this ever-present danger, developing a culture of preparedness and resilience. Tornado sirens are a familiar sound in these areas, signaling the need to seek shelter immediately. Schools conduct regular tornado drills, teaching children how to stay safe during a storm. Many homes have storm shelters, either underground bunkers or reinforced safe rooms, providing a secure haven during a tornado. Communities in tornado-prone regions have also established early warning systems, utilizing weather spotters, emergency sirens, and mobile phone alerts to notify residents of approaching storms. These early warnings are crucial for giving people time to take cover and minimize casualties. Section 8. Preparedness is key, staying safe in the face of a twister. Knowing how to prepare for a tornado and what to do during a storm can mean the difference between life and death. The first step in tornado preparedness is to have a plan. This plan should include identifying safe shelters in your home, work, and school. Basements, storm cellars, or interior rooms on the lowest level, away from windows, are the safest places to be during a tornado. It's also essential to have an emergency kit readily available, containing essential supplies such as water, non-perishable food, a first aid kit, a battery-powered radio, flashlights, and extra batteries. During a tornado warning, time is of the essence. Seek shelter immediately and stay tuned to local news or weather radio for updates. If you are caught outdoors during a tornado, do not seek shelter under an overpass or bridge. These structures can actually amplify the wind speeds, making them more dangerous. Instead, find a low-lying area, such as a ditch or ravine, and lie flat, protecting your head with your hands. Section 9. The Future of Tornadoes, a call for vigilance and adaptation. As the climate continues to change, the threat of tornadoes is likely to evolve. The eastward shift in tornado activity, the emergence of Dixie Alley as a hotspot, and the increasing frequency of tornadoes outside the traditional spring season all point to a future where these storms pose a greater risk to a wider swath of the United States. Adapting to this changing threat requires a multifaceted approach, including continued advancements in tornado forecasting and warning systems, enhanced public awareness and education, and investments in resilient infrastructure and community preparedness measures. By understanding the science of tornadoes, heeding the warnings and taking appropriate safety precautions, we can mitigate the devastating impacts of these powerful storms and build more resilient communities. Remember, when it comes to tornadoes, preparedness is not optional, it's essential.